Welcome, everybody. Thanks so much for joining us. We'll just allow a couple of moments for everyone to get in. There's a lot of people joining us today. We're certainly very appreciative of your time. Yeah, a lot of people coming in now. I might get things kicked off. If we don't, if you sort of arrived a little bit late, don't worry about that too much. We will get a copy of today's recording to you. So please don't worry about that. But a very big welcome to this session on navigating the future of energy projects, which is hosted by Arche Energy. My name's James Cashmore. I'll be moderating today's session. I'm going to cover some very interesting topics whilst looking at the increasing complexity of energy projects and the growing need for sustainable solutions. And as we know, energy providers face numerous challenges in project management, regulatory compliance, and technology integration. So we'll hear from our guest speakers, Andrew Murdoch and David Nolan, in a moment. Before we do, just a little bit of housekeeping. The main session will probably run for around 30 minutes, could be a bit longer. I've got a few questions to be able to ask our guest speakers. But I would encourage, if you've got some particular questions yourselves, please put them in the question section below. We'll endeavour to get to as many as we can. And if we haven't got time, we will reach out to you post today's session to be able to answer as many of those as we can. Today's session will focus on project development and management, GIS and data analytics solutions, electrical design and compliance, maximising project efficiency, technology integration in energy projects, and of course, some questions if we can get around to it. So I'm looking forward to that. So with that, delighted to welcome and introduce our facilitators for the day, Andrew Murdoch and Dave Nolan. How are you both? I hope you're well.
Yeah, good, thanks,
I'm well,
James.
thank you, James.
Good. Andrew, you've been operating in technical commercial roles, Queensland, since it was first founded, Arche was first founded. You provide, high quality, clean energy, power and infrastructure consultancy to facilitate investment in the clean energy sector. A lot of experience as a general manager, project director, engineer, operating in renewable power generation, energy ports and heavy infrastructure. So a hell of a lot of experience, Andrew. I just wanted to thank you very much for your time. Really looking forward to hearing from you today.
Thank you, James.
And Dave, MBA qualified mechanical engineer, over 25 years experience in the mining, construction and rail industries. Excellent people management, communication skills, as well as business development expertise. You got proven experience in engineering management, study management, project management and coordination of technical teams and design office and construction. I mean, I could go on, but it's very clear that you're an expert in your field as well, Dave. So a very, very big welcome to you and thank you very much for making your time available.
Thanks very much, James. Good to be here.
Thanks. I might just get kicked off, and Andrew, I might just direct this first question to you, but I mean, every time I talk to developers, I keep hearing about approval risks, for example, timeframes and budgets blowing out. I suppose the first question I'd ask you is, how do developers protect themselves from costs and schedule blowouts? Got some thoughts there?
Yeah, thanks, James. Yeah, so it's a good question, and obviously core business for Arche Energy is helping developers take their energy projects from concept through to financial close. So we help our clients manage some of the risks and challenges associated with developing energy projects. The first thing I'd say to clients is, number one, is get the concept right, build the right project in the right location. And that means doing things like understanding energy flows and the network infrastructure. So what's happening to energy in the local region? Is my generation project or storage project going to assist energy flows, or are they going to make congestion worse in particular locations? So can I actually get my energy to market? I'd also sort of encourage people to have a good look at approvals, constraints, and environmental overlays on the project, and have a very good view as to how you're going to build your project in a way that minimises impacts on on areas that are particularly sensitive or challenging, and whether that's remnant vegetation or incompatible land uses, etc. And this is where having a good GIS system set up that can overlay both the network as it is or as you want it to be, and the relevant planning constraints over the top of it, so that from the get-go you're building a project that is going to be sympathetic to both energy flows and environmental constraints. I then go on to say, build a realistic plan for schedule and budget. Whatever you do will take longer than you think and will always cost more money than you think. So being realistic in your planning and making sure that your development budget is sufficiently robust and time frame is sufficiently robust to deal with the unknown unknowns. Rules change over time. It will take you more than an election cycle to do a reasonably complex project, and in that time frame, things will get more difficult as more regulation comes in. Even perhaps when governments are here to help, they sometimes just help by making things a little bit harder. I'd say on that is understanding what the regulators' needs and constraints are. Regulators are constrained by a piece of legislation or a planning scheme or a set of national electricity rules, and we have to understand what those rules are, because the regulator is going to respond to what those rules are, and there's very little room for discretion that the regulator has. So understanding how the regulator is going to behave in particular situations helps us frame the arguments and essentially make it easier for the regulator to assess the project and hopefully assess it in a way that is positive for our clients. Early engineering helps in that regard. So minimizing the requirements for minor changes. So doing the work early to define the project well, so that impacts are known, and whether that's impacts on the electricity network or environmental impacts, doing the early engineering certainly helps and minimizes the need to go back to regulators for things like minor change requests, for example. Doing thorough work is important. So selecting quality advisors, and whether that's ecologists, whether that's modelers to do the generator performance standards tests, whether it's selecting a good town planner, selecting a good team of engineers, selecting good quality advisors who are going to do thorough work is going to help minimize risk and time frame.
Okay, thanks for that, Andrew. I might just bring you in here a little bit, Dave. I just wanted the audience to understand the challenges that you think are facing generation project developers in the renewable energy zones. You probably have some thoughts there. What are you thinking?
Yeah, I've recently come from a New South Wales renewable energy zone project, and yeah, I think there's a lot of lessons we can learn for some of the experiences there, but certainly challenges include things like the community engagement and social license to operate that a lot of the developers will find, and seeing trends like projects looking for larger plots of land and relatively fewer landholders to have to negotiate with. Certainly regulatory approvals can be quite challenging depending on the jurisdiction, and delays there can really affect project viabilities. Commercial challenges, I think it's very important for the infrastructure planner or the renewable energy zone coordinators to make sure they get the balance right as far as access fees or transmission connections or community benefit payments. I think that's very important to get that balance right, to make sure that they're not going overboard or charging excessively there. And I think the other important thing in terms of commercials is to things like storage. How do we get the energy storage mix right, and how to incentivize that properly? And certainly technical challenges. For example, in New South Wales, the existing grid is, it's fair to say it's at at capacity or very close to it. It's not really designed for the energy transition that we're going through at the moment, with lots of regional generation trying to get back to population centres. The stability of the network, that's a really important piece of the puzzle. And how do we model that? How do we understand what the best solution is, whether it's lots of very capital intensive synchronous condensers or syncons, whether you allow generators to self-remediate or contract that system stability from third parties. How do you decide the best connections to res hubs and minimize impacts to landholders, and getting the hub layouts and architecture right to accommodate storage and avoid flooding the NEM with lots of solar energy during times of minimum demand. And that's a big challenge that AEMO's got across the NEM. And I suppose modelling the stability overall, that's a real challenge yet to come in terms of the technical challenges for all these reses to look at the impact of a lot more renewable energy coming into the NEM. So
some really good insights there. Thanks for that, Dave. Makes I think us all think a little bit about how we step into that. Andrew, I seem to recall that you were mentioning that Arche has recently established its advanced GIS and data analytics team. I suppose I just wanted to maybe understand how you feel that adds value to the clients that you consult with on a daily basis.
Yeah, thanks, James. So I mentioned before about building the right project in the right location, and that's really, I guess, the intent in us building a GIS and data analytics capability is to help our clients in terms of their prospecting, to find good locations, to help assess locations for generation projects, and whether that's solar farms, wind farms, battery projects, gas turbine projects, etc. That our GIS tool will help our clients do that. I'd make the comment that data alone is just noise. You need some degree of analytics to make better decisions with the data that we're given. There's plenty of access to data out there in relation to energy, and most of it is free, and most of it is downloadable from various government and other providers. The challenge that we find is establishing the right data set, and there's a lot of work that our team has done in establishing an up-to-date single point of truth for the entire transmission network in Australia, including the Northwest Minerals Province and the Pilbara and Southwest in WA. Pulling all of that data together into one place is a lot of work, and then making sure that data is up to date and maintained is also a lot of work, and that's a service we provide for our clients that use our GIS tools. Data by itself won't tell you what's relevant and what's not relevant. You need a degree of, I'm going to say, human intelligence to overlay data, the data that we're seeing, to translate that back into what does this mean for the market? What does this mean for the commercial decisions that I'm going to make? And I guess the electricity industry is very complex in that you've got marginal loss factors that impact revenue and cost for storage projects that varies by geography, and that can vary quite significantly. It also varies by impedance of transmission lines connecting one geography to another. You've then got an overlay of, well, there's a solar resource that increases value as you go west. There's a wind resource that increases value in places like the spine of the Great Divide, for example. And overlaying all of that, what's the value of different pieces of real estate in different geographic regions in terms of the energy projects that we want to develop, and again, whether it's wind farms or solar farms or battery farms. and sort of helping pull all that data together to help our clients make better decisions in terms of whole of life NPV of projects. The other aspect as to what the GIS team is doing as well is doing some smart asset management and construction management type tools. So we're currently working on a project where it's a construction project, and the GIS tool is going to allow our client to be able to click on a piece of equipment and or click on a location, and that particular location, it'll say, okay, well, we're going to put this particular piece of equipment here, and it's going to be this big by that big. It's going to do ABC, X, Y, Z. Then once the project is built, they'll be able to click on the particular piece of equipment in the geographic location, and it'll pull back to the maintenance records of that particular piece of kit, so that you can see when it was last inspected, when it was last serviced, etc. So sort of establishing the tool that starts at project development phase is there as a useful tool during construction, and then will be continue to operate during the asset management phase, is going to be very, very valuable for our clients. Right,
thank you. Quite informative. I want to take, maybe Dave, just go back to you for a moment. Sort of mentioned and sort of a whole bunch of different challenges across the renewable energy zones, the res zones. Just what do you think governments might be able to do to help solve some of those challenges? What are your thoughts there?
Yeah, well, look, a lot of the big infrastructure can only be delivered by government. So to some of the res infrastructure in New South Wales is going to be really what the state needs. Is 500 kV infrastructure going in. It's going to be really great capacity for transferring the sort of scale of energy that the state will need. But the government's role within that, I think it's firstly got to take the view that the generation is an important part of the entire res. It's not just a transmission project, but it's a generation project, or it's multiple generation projects by private industry connecting to a piece of public infrastructure. So things like approvals, I think a really smooth, efficient and timely approvals process is essential, critical. And 9.5 years for approvals for wind projects isn't going to work. It creates a lot of risks for wind developers, for example. Things like access fees are also quite important to the financial model for the generators, can affect the viability of the generator projects, and ultimately could it have an impact on the energy pricing for consumers as well. So quite important. The legacy, the scale of these projects supports a lot of legacy infrastructure. So things like workforce accommodation to actually deliver the scale of transmission infrastructure and all of the generation projects going into these reses will create huge opportunities for things like legacy accommodation for workforce that might be used for workforce camps now could be turned into permanent infrastructure for years to come. And there's lots of opportunities like that. Transport infrastructure, road upgrades, bridge upgrades, training and workforce opportunities, material supply, lots of opportunities like that. And I think governments need to be open to the opportunities of those things and be proactive in solving those challenges ahead of time.
Okay, good points. Thank you. Appreciate that. Andrew, maybe one back to you. I know that you've been helping a lot of clients of yours overseas with technical compliance. I suppose my question might be, what are the key aspects you're seeing of engineering compliance? Have you got some thoughts maybe to share with the audience there?
Yeah, so one of our projects is essentially to help an international engineering house provide detailed design to a gas turbine project in Australia. In this particular gas turbine is going to consume a a combination of hydrogen and natural gas. So there's quite a few technical and compliance challenges associated with that particular project, given the nature of the two fuels that we're using, and the fact that there's not a lot of experience in burning hydrogen and gas turbines in recent years. So we sort of come back to some of the fundamentals of some of the fundamental tools in safety and design, such as failure modes, effects and consequences analysis, HAZOPs, fire and gas explosion risk assessments, and similar safety and design tools that are really designed to flesh out what the risks are, what the consequences are, to highlight the areas that need a more thorough risk decision to be made around them. We also need to take into account the relevance of Australian standards, and if you've not been brought up with Australian standards, how do you interpret them? How do you apply them? How do Australian standards work with the risk management tools, and understanding where you just have to strictly comply with the Australian standards, and when you need to apply a degree of judgment and add layers perhaps above and beyond the requirements of the Australian standards. We also need to take into account the role and requirements and responsibilities placed on registered professional engineers of Queensland or Victoria. So for the two states that have registration requirements and that place a specific obligation on the individual engineer, and what they're personally responsible for, and how we support the individuals in making risk decisions, and essentially allowing them to do their job properly. Also recognizing that design is iterative, and that safety and design factors will actually have an impact in terms of scope creep and schedule creep, because you'll start with a concept and then you'll do some safety and design, and you'll realize that you've got to really put a little bit more focus in a particular area, and then you've got to go back and say, okay, well, you know what, we actually can't meet that schedule, because we can't meet the original schedule, because we really need to spend the time and effort to drill down in a little bit more depth in this particular risk area. And it's not to make excuses, but it's also just to be aware that if we don't perform our safety and design obligations, then the project's not going to proceed, and there's individual liabilities and risks that our clients won't be thanking us for taking. So making sure that we're having a hard conversation early in the piece. Bad news early is good news. To make sure that we're using the tools early, doing the work early, so that the impacts of the risk decisions that perhaps you don't want to make, that the impacts on schedule and budget are dealt with early in the piece. And again, that also comes back to doing a little bit more engineering early, defining the project well, so that you can make these decisions earlier before they have an impact on a negative impact on schedule. So yeah, working through, and I guess you make some risk decisions at pre-feasibility time. Then as you move into FEED, you make more risk decisions at the 30% design completion. And then you come back and revisit them at 60% and go into a little bit more detail. You revisit them again at 90% and go into a little bit more detail. And then at IFC stage, you also go into a little bit more detail. Compliance is complicated. Electrical compliance is different to fire compliance, is different to hazardous areas, and it's different to Type B certification, and you need different advisors for the different stages and the different particular technical areas. And again, having a network of good advisors is key to this process going smoothly, and also thoroughly as well.
Got it. Thanks so much for that. Dave, before I bring you in here, just to the audience as a whole, if you do have any questions for Andrew or for Dave, please put them in the question area below. We will try to get to as many as possible. We've got about another 15, 20 minutes left in the session, but just in case you had some specific questions, please feel free to put them down there. I will try to get to as many as I can. Dave, another one really for you. I suppose what I wanted to maybe ask are the biggest opportunities for developers in the res that you were discussing earlier. I mean, we sort of talked a little bit about government, what they can be doing, talked a little bit about the challenges, but why don't we have a bit of a chat about the opportunities as well? What are your thoughts?
Yeah, so thanks, James. Look, I think the res, the principle behind the res is worth talking about as well, because, or any res, is that that it's purpose-built infrastructure for transmitting, renewable energy to a population center. So the purpose-built, as in 500 kV, can be up to 500 kV infrastructure, which is probably as high capacity as is reasonably achievable in Australia. You've got, with that purpose-built infrastructure, you've got, very low curtailment risk. You're very likely to have really good marginal loss factors. So that's really good for the financial models for these generators. When for every kilowatt hour they produce, they'll hopefully get a decent return for that. So there's definitely incentives there for the generators. Things like the commercial frameworks being put together. It's really pleasing to see the Federal Capacity Investment Scheme tenders going ahead. They've had really good responses on those. The underwriting agreements are similar to the LTESs, or the long-term energy service agreements that they're using in some of the reses. And that does seem to be welcomed by the industry to de-risk projects. I saw that the CIS tender stage 1, or tender 1, closed at 6 gigawatts of capacity. They've got 2 current tenders open, tenders 2 and 3. The tender 2, I think, is 500 megawatts in the Western Australian energy market. Tender 3 is for 4 gigawatts or 16 gigawatt hours of storage in the NEM. I think bids close on that on the 11th of December. And they've recently announced a tender 4 for another 6 gigawatts of capacity, and those registrations close in February 2025. So there's lots of opportunities there. I guess the balance has to be struck between the infrastructure planner and the generators around who's, everything's got to work. It's got to be a win-win for the generators and for the infrastructure planners, for that to all put together. I think the biggest opportunity I see growing and more is around the firming capacity. That does seem to be key to a lot of the projects we're seeing. I guess it also so happens that Arche, that's really one of our core competencies in terms of our ability to put firming projects together, including very large BESS projects for Supernode and Lockyer, and also gas turbine type projects. So that's probably more and more I'm seeing generators adopting larger and larger big batteries, but also we're seeing other clients with baseload demand looking at gas turbine or big large batteries for firming with energy, with renewable energy as well. So
great, thanks for that, Dave. Quite informative, and I think there's a few opportunities. I know a couple of questions have come on the back of that, which I'll ask in a minute. But Andrew, back to you. I suppose every time I open a paper, it seems that I'm reading about a major project that's over budget or behind schedule. I suppose the question I have is, what are the practical things that project managers and others can do to deliver, a project on time and on budget? Maybe you've got some thoughts there.
Yeah, so look, the iron law of mega projects says that every mega project is going to come in behind schedule, over budget, and under deliver on promises. My take on the iron law is that's generally applies to projects that are rushed to market, that perhaps are initiated by a political announcement with limited feasibility and limited cost benefit analyses. So I'd come back to saying, build the right project in the right location for the right reasons. So before you even get to answering what's the right project, is having a good understanding of what our objectives are for the project that we're trying to define. And before we get to financial close on a project, is making sure that we've got we've got a realistic budget and schedule, and that we've done a robust cost benefit analysis for the project. And how do you get there? Well, you get there through doing a thorough feed, front end engineering and design study, and out of that you're developing a realistic budget and schedule for the project. Moving on then to where you see the practicalities of projects not going perhaps as well as they should. Some of the things that the developers and owners can do is structuring our contracts in a way that where contractors are responsible for the things that they do well. And perhaps not things that they don't do so well. And also structuring the contracts in a way that the contractors are responsible for the risks that they can manage well. And that might mean that the owner carries some of the residual risk, but that might be a better way, a more efficient way of doing it than forcing a contractor to take on risks that they haven't managed before, or they have no control over, etc. And the classic one is currency risk, for example. Is a contractor, a construction contractor, a good entity to manage currency risk, or is your banker a better entity to manage that risk for you? And perhaps you might choose to manage currency risk yourself with the help of a good banker, rather than forcing the contractor to take currency risk. Of course, there's more than one way to do these things, and what's right. That particular solution doesn't necessarily is not necessarily right for every project, but just understanding what your contractors do well and what they don't do well is a good way of de-risking the project. I'd also say that taking the opportunity to manage risks yourself as well in an active manner allows you to view every risk as an opportunity, and perhaps improve the bottom line of your project. So for a contractor pricing up risk, they're going to essentially put a premium on the contract price. Well, they'll do one of two things. They'll either put a premium on the contract price because they know that the risk is going to cost them money, and they're not well set up to manage it. So you pay for that in premium, or they'll not put a premium on the project and perhaps not manage the risk so well, and end up with problems that impact the delivery of the project, whether it's cost or time, that you will end up managing. And in the worst case, will make your contractor will go into administration, and you're left with a half-built contract, and that never ends well for anyone. So moving on to other areas that I've seen issues is in approvals, particularly things like minor change requests, where you race to financial close, you get the golden shovel out there and have the sod turning ceremony, and the announcements are made, but you don't quite have the minor change approvals in place to build the project exactly the way that you want to build it, and you hurriedly go back to the planning authority and put in a minor change request application, but it takes longer than you think, and then all of a sudden you're in a situation where there's big yellow trucks on site costing hundreds of thousands of dollars a day, digging holes, etc. But they have to stop because you don't have the right approval to build the final design of the project, and that obviously gets very expensive very quickly. So understanding the approvals that you need, and approvals are complex. So understanding them and getting those approvals early is important. Buying quality kit, there's no price for a lemon. So making sure that that in your procurement exercise that you're not compromising on the quality of your equipment, and whether it's solar panels, whether it's inverters, whether it's batteries, whether it's gas turbines, whatever, is making sure you're spending the time during the procurement phase to buy quality kit. Your project management team will have a big impact on the performance of the project. Your project management team needs to be led by a project manager or project director who essentially is a high EQ person. You don't want you want people who are going to lead, but you also want people who are going to lead in a manner that that people are going to want to follow, and in a manner that allows them to make pragmatic decisions as to how the project will be executed. That PM needs to be supported by a good project controller, someone who knows how to drive P6 well and is capable of cutting through the less accurate information that might be provided in project reports, capable of getting to the truth as to what's happening and what's not happening, and that allows the project manager to make better decisions and better decisions earlier, as soon as the project's controller's spidey sensors start to indicate that there might be trouble with a particular work stream. The sooner the PM knows about it, the sooner he or she can start asking some hard questions about what's going on. And as a project manager, project director, one of the most important things is to be honest with yourself, your project team, and your customer / client / boss, because the sooner if your project is going south, the sooner you detect that and make a decision to rectify it, the easier it is going to be to rectify the issue. The other comment I'm going to make on project team is that it doesn't matter whether that project management, whether it comes through an EPC contractor, whether it's provided through an EPCM contractor, whether it's provided by the owner's own delivery team. At the end of the day, it's not so much about the project structure. It's not so much about the contractual structure, but about the quality of the people in the project management team that dictates the success or otherwise of the project. Because it really, the owner ends up paying for it anyway. It's more dictated by the quality and capability of the people on the team than contract structure.
Okay, great. Thank you. Good answer there. This probably could go to both of you, but maybe Andrew, you might want to give it a first stab, and then Dave, you might want to come in. But I think it'd be fair to say that Arche has been quick to recognise the commercial role of new technology. So I suppose, if I remember back, you sort of started looking at those large-scale batteries back in 2017 and then quickly recognised their value in the market. So I suppose my question is, why do you think it's important to quickly understand the commercial strengths and weaknesses of new technologies, and how would people go about it?
Yeah, thanks, James. So yeah, look, when I started in the power industry in Queensland, the industry was 99% coal and a couple of liquid-fired gas turbines. So very different to what it is today. I remember as a graduate being told that I should go and research what a CCGT was and work out how it works, because perhaps we might build one day. We had some experimental wind farms up at Windy Hill to play with for us graduates. I guess in terms of understanding, so I've seen a lot of different technologies come into the market and go from sort of good idea to maybe someday this will happen to actually there's some physical kit out there in the plant, out there in the real world being built. In terms of when I think about new technologies coming in, I think about the NEM, the complexity of the NEM, and understanding the various different sub-markets. And if I divide the NEM up into sub-markets, and just in energy alone, you've got base load as a sub-market, you've got peaking load, firming as a sub-market. You've got renewables backed by LGCs as a sub-market. You've got frequency control as a sub-market. You've got management of intraday 5-minute to 5-minute volatility as a sub-market, and each technology that is out in the NEM today addresses each of those sub-markets in a slightly different way. Some of them are capable of addressing most of those sub-markets. I don't think there's a technology that do all of them well. And there are some that only address small areas of each of those submarkets. So really understanding how is that new technology going to make money? What part of the market is it going to address? So you'll find various different technologies as they come up, as they hit the press. They become popular. Some of them are economic, some are not. A new technology, it needs to solve a problem, and at scale, it needs to be economic. If it doesn't do those two things, then it's not going to be sustainable and viable in the market. Some technologies are a solution that need a problem. Lots of good ideas out there, but they're not going to be commercialized until they're capable of solving a problem. So I'd sort of say when either developing a new technology or assessing a new technology is understanding the nature of the revenue that the technology is chasing, understand the costs and the physics that are required to operate that project, understand how the physics of the technology generates value and how that value flows through the value chain, and that sort of allows you, with that sort of physics to dividend thinking, sort of allows us to make good decisions and provide good advice with respect to the suitability of new technologies for the market.
It's also worth pointing out too, I think that for example, solar is already at massive scale around the world, and it's well down on the cost curve in its development cycle. So it's it's going to be very, very competitive compared to many other technologies that are out there. Certainly better solar, yes. We're seeing things like flexible printed cells and things like that could be one day on the equivalent of a printing press and just literally rolled out to any curved surface or on the side of a car or on the sides of buildings, or these other type of technologies could occur. But and wind's the same. We're seeing 6 megawatt turbines offshore. They've got 8 megawatts up to 15 megawatt turbines. I think there's other larger turbines being sort of proof tested now, but those are if you like, the incumbent in the renewable energy generation space right now. And new technologies, as Andrew's saying, have to be they have to deal with that incumbency and have to do something better than what we're seeing with those, because there's a massive cost advantage in those incumbent technologies as we're seeing them at the moment. And certainly batteries also being rolled out at scale. Other technologies for battery storage will need to be as good or better to be able to compete at scale.
Okay, great. Thanks so much for that, Dave and Andrew. I really appreciate it. I mean, there is heaps and heaps of questions that have come in from the audience, and to all of you that have asked questions, thank you so much. We genuinely appreciate it. We won't be able to get to all of them, just given that we've only got a few minutes left. I might just quickly, Dave, I think this one really was pointed to you. You were talking about sort of once in a lifetime opportunities, but the question from Jonas is really around him seeing very little on new innovation and changes in the way, we maintain the assets. We now build, we're still planning to send field staff or field service staff around to check status rather than new technologies on predictive maintenance. I just wanted to see whether or not you could expand your views on that, or you had some additional thoughts, and maybe Andrew, you do too. I might just close on that question.
Well, look, I mean, I'm probably not the expert in this field, but I think things like drone technology is getting better every day, and things around asset inspection can be really can leverage drones, I think, in a big way. For example, for a wind turbine, for the scale of a single turbine can be 160 meters to the hub, and then another 100 something meters, call it a 100-meter blade, so making a tip height of 260 meters off the ground. And the tip heights can be whipping around at quite high speeds as well. So having a small drone that can do 4K inspections up close on hard to reach areas like a wind turbine could really reduce costs a lot. And certainly for a solar array, the same thing. You've got large fields, hectares and hectares of solar arrays. So you can do that at scale and have airborne asset inspections that can be done cheaply using those kind of technologies. I see a lot of potential there.
Yeah, and I think also in my career where we've gone from things like having visual inspections of under and over weirs to detect oil leakages, for example, you've now got some fairly advanced technology available to detect minute traces of oil in transformer bund runoff. We've got things like incredibly precise power quality meters available to us now to help us stabilize the grid, for example. So some of these technologies that are available now are fantastic, and in terms of asset management, what is available now compared to when I was a graduate is amazing.
Great. All right, well, that's about all the time we have today. Andrew, David, I certainly wanted to sincerely thank you for your time. I appreciate how busy you are, but I think this topic is of great interest to a lot of people. We've had a considerable amount of people online today and a lot of people registering. So I want to thank you all for attending today. I appreciate you've also got busy schedules. We're leading up to the Christmas and New Year, and undoubtedly you've got a number of things going on. So it's great to welcome you and have you here today. I hope you got a lot out of today's session. We'll certainly reach out to those that have asked questions, and probably to others, just to be able to see what you're currently doing, whether or not you've got a few projects and other things that you would like to discuss with Andrew and David specifically. So we'll reach out to you post for that. Other than that, keep looking out for these sessions. We're going to be doing more and more into 25. And if you have some interesting topics that you'd like Andrew, David, and the rest of the team to potentially answer, don't be afraid to pop us a note. Let us know what you'd be interested in being able to hear more about, and we'll certainly start putting that into the presentations we have for next year. Again, Andrew, David, thank you so much for your time. Have a fantastic day. Thank you.
Thanks, James.
Thanks,
Thanks everyone online. Talk to you soon.
Thanks for joining.